cover theory a little bit.
Theory is like I think 4 5 hours like too much. So maybe like watch the lecture, that will be sufficient. Professor explains
Okay.
all the things. Maybe that graded assignment is there, right?
Yes, yes.
So that you have to create a circuit diagram in circuit bus, then export it as file name question number.csv. After creating all the question, compress them into a zip file and submit it. So first is design a 8-bit register in circuit bus using 1-bit D flip-flop with IO control, and second is design an 8-bit ALU circuit bus with add subject control, right? So maybe like that practice assignment question is little bit difficult, so maybe I'll solve that this question, that will be help for the graded assignment, right?
Okay, okay.
So answer question 3 and 4. So this 3 and 4 based on the given information. So first you have to design an 8-bit register using 1-bit D flip flop. So let's design that. Let's go to circuit bus.
You need to share your screen.
Oh, I'm not sharing. Sorry. So first question is design an 8-bit register using 1-bit D flip. My screen is visible, right?
Yeah, now it is visible.
Okay, so first you have to design a 8-bit register using 1-bit D flip flop, right? So let's design 1-bit like that 8-bit register using 1 D flip flop, right? So this is D flip flop, right? So this is D flip flop. So you have to design. So we require 8 D flip flop, right? Hi Pritadeep, what are you doing?
Good evening, sir. Nothing specific, just thought of hopping by.
Yeah, yeah. Good to
Uh,
have you here. I mean, that increases the number.
Okay, so that's the another is 8-bit registers. So another is then, so let's do 8, 3, 4, 5, 6, 7, 1, 2, 3. I'm forgetting. 1, 2, 3, 4, 5, 6,
yeah, it's
7,
it.
8.
Yeah, that's
Yeah,
correct.
8. So we have to take input, right? So I repeat. So there is a bit width. So you can increase to 8. So 8. So it will be. You can see that it will be 8. Now we need splitter, right? So that is splitter. So that is a splitter. So first is insert bit width, right? So it is 8.
So
Then
right now, this one, this the one in yellow.
yeah,
What is this called?
input. That sorry. That is input.
Okay.
Whatever we can give input here, 1 0, whatever you
No,
can
from
give.
where we collected this? This.
Input, that is input.
Okay. And we
Now
expanded it, and
yeah,
bit width we expanded to 8. If
yeah,
we
correct.
do it one, it will only show one cell.
Yeah, yeah, it will also on.
And on the right hand side, these are 8 numbers of
Flip flop, D flip flop.
D flip flop.
Yeah.
Okay.
Okay. Now we need splitter, right? So splitter basically uses like it will like converted the 8 into the 8 things, right?
It will connect to 8 different
Yeah.
things.
So
Okay.
interpret it 8. Then how it will convert it? 1 1. Then 2 3 4 5 6 7 8. So it will convert in the 8. So let's connect. So it will convert into 8. Then you have to give the 8 things input.
Okay. That from dot we are
Yeah,
extending.
yeah.
So the clock will be the same across the D flip flops,
Yeah,
right?
yeah,
Across
yeah,
the, yeah.
yeah, we'll do, don't worry. So, so then, right. Now we have to put the clock also, right? So let's put the, here it's clock. So let's all connected. This should be same, right? For right.
One is
Okay. So this is clock, right? So that's
one is pending, seventh one.
okay.
Yeah, you missed one of them.
Okay. So now clock. So maybe so the register should have data in, data output, and data in control, data out. Okay, then which control the read write operation. Next, design the circuit using three such register ABC ROM. So maybe first we'll put the clock. We'll see it's working or not. Right. So in the clock, then I can see that data in the register should have data in and data out control, right? So that's why this is enable. So if you enable is equal to 1, then it will work. This T flip flop will like work, otherwise it will not work. So let's do for all the things. Enable.
Excuse me, sir. One question. So the practice assignments do not count towards bonus marks, right? For CSD.
There is no bonus mark in the CSD.
Yes.
Right, right. But some of the practice assignments, it was written on top of them that it will be considered for bonus marks. Therefore,
Uh,
I asked, but it might
for,
be a misprint.
for degree level, there is no bonus mark.
Yeah, exactly, exactly. That's
Uh,
what.
yeah.
Okay, maybe we'll have to rectify this because it mentions it on the top of certain assignments.
Yeah.
Yeah.
Yeah. So in deep learning also, I raised the same thing. Anamika ma'am told that this needs to be corrected,
Mhm.
but they have
Right.
separate section for bonus marks.
Bonus marks. Yeah, exactly, exactly. That
So deep
part is there.
learning and artificial intelligence, they have separate activity for bonus marks.
True, true.
Yeah.
5 marks, right?
Yes.
Okay. So
Ritodeep had 10 marks.
Yeah. In my case as well, I think.
yeah.
Oh,
Because me and Prithadeep did at the same term. AI as well as
great.
Okay.
yeah, the other one.
Okay. Then that should be register out, right? So we'll using tri-state buffer, right? So this is the tri-state buffer. Okay,
You
bye.
can ignore that message. Yeah, I was sending it to the others. Bye.
Okay, bye bye. Thanks for joining today. Okay, so we'll be using tri-state buffer.
So what are the three types of elements?
So this tri-state buffer. So if this is equal to 1, so we'll put this 1, then it will print the output. If this is equal to 0, then it will not print. Like connection, like kind of the wire. Think about the wire. So if 1 means it's like wire is joined, and
Mhm.
it's 0 means
Okay.
it wire is cut out.
Okay.
Okay.
Excuse me, sir. Could you please zoom in a little bit so that I mean, like, if possible? Yeah,
Yeah.
yeah. Yeah, thank you.
So
So the outputs of flip-flop are connected to this
yeah. So if it is
tri-state.
yeah tri-state buffer. Basically, this is a graded assignment 1.
No, this is practice assignment.
Yeah, but design a 8-bit flip-flop.
After that, questions are other thing.
Yeah,
Yeah,
yeah.
but
So okay. Now this is registered out. And we'll connect to this all. What happened? This is registered out. And then okay, so let's give that output. So output will be this, and it will be 8-bit, right? So this will be 8-bit, right? Again, it will require a splitter. So it again it will be 8-bit, and it will be 1, 2, 3, 4, 5, 6, 7, 8. And this will be direction will be direction. Okay. This will connect to this.
sometimes these don't get keep getting connected, particularly in XOR gate.
Huh?
In XOR gate,
Huh?
sometimes it becomes difficult to connect to the gate.
Why?
I mean, either it crosses the dot point or
Uh,
gets short of the distance.
it's very simple, right? XOR gate.
XOR gate or some other gate. I mean, there is only one thing to be connected there.
Okay, maybe. Okay.
I'll tell you later.
Okay. Now let's see. Clock is enabled. Now, if you put sub register in, it's register out also one, and you can see that sub register in also one. So if you like change the things, then you can see suppose all are 0, 0, 0. You can see that all things are 0, 0, 0. If you this is the input, right? So this is the input. If you change in the, and this is the output, right? So if you change in the any input, it will reflect in the output, right? Suppose register out is 0, so you can see that it will be all kind of like nothing, disconnected. And suppose a register is 0, so you can see that if you change anything, it will not reflect in the output. You can see that it's not reflecting the output. If register is equal to 1, then it will reflect in the output. So this
Yes,
is,
register in is 0. That means nothing is getting.
yeah, nothing is getting. whatever the previous value was, that just printing. So D flip-flop, it's clear for
So
everyone.
one more question here. Sorry to interrupt. So what happens? Say there are four cases, right? If register in is 0 and register out is also 0. I mean, if register in is 0 itself, then there is no question of it going forward. So that's okay. If both are 1, then it is copying. And now what about the other case? If register in is 1, however, register out is 0, then what happens in that case?
Register, if register out is 0, then nothing.
I mean, it is the same. The effect is the same as in if register in itself is off, right? I
But
mean, doesn't matter.
See that OR is like disconnected, so it will get nothing, right?
Hmm. hmm.
This
Okay. No. What I'm trying to ask is that whether I make register in 0 or register out 0, the effect is the same, right?
no, no,
Does
no,
not matter.
no. If see, suppose register one
Register in, if it is 0, then
Mhm.
it whatever is the previous state, it is produced.
yeah,
Mhm.
correct.
Okay. It retains that, right?
Yeah,
Basically.
correct.
Yes.
And here is kind of simple OR. See, just disconnected.
Okay.
So
Okay.
let me depend. It's a tri-state buffer is kind of a OR. So kind of a OR. So if you just disconnect, it will get nothing, right?
Okay. So it's like a switch, right?
Yeah, it's
Basically.
like switch. Yeah, correct.
Okay. Okay.
So
So
if
All right.
by this design, what did we achieve?
this is the
Yeah. I mean,
8-bit register. This is the 8-bit register. What is do mean by register? Whatever you can store the data, right?
Stored, yes, stored
storage. Yeah.
permanently. I mean, or temporarily.
Yeah. So if you put anything in in, it is stored, right? Whatever the things.
Correct. That, I mean, in we have this registers and cache. So that
Yeah.
register, we need to store the data temporarily.
Yeah.
So we are doing this.
Yes.
And input is
Okay. And
coming from.
Input is like whatever you want to give input. Like just click the mouse, it will give the input.
so one more question, sir. So the bit width is going to be mostly 8-bit, right? Only, I think so.
Yeah, you can increase also. If you want to increase, then you have to increase the D flip flop.
Yeah, that is true. But in general, I'm asking. I mean, like mostly the questions are revolving around 8-bit only, right? I
Yeah.
mean, I think
Yeah.
because otherwise it'll become more complicated. I think it'll not become complicated as such. I mean, mostly it is D flip flop only, so there's nothing complicated. But then again, I mean, the number of bits might increase, and therefore a lot more connections have to be made, right? Into these wires have to be connected and all that. But it's okay. I get the idea.
Yes.
Yeah, I might
So
try doing it.
this is a part of ALU, no, register.
Yeah, this is a part of ALU.
So what is an ALU? What does ALU look like?
ALU, ALU is like see ALU is like you can say that whatever the ALU, it take inputs from registers, not a part of that. It's taking input from. Okay, so maybe I'll show that.
So
I-
see, a CPU consists of registers and ALU.
Okay, so let me stop the screen. I'll share that how actually ALU look likes. But okay, on me. Stay opening. Dashboards. Registered secure. See. So my screen is visible, right?
Yes, it is now.
So this is the ALU. So ALU consists of a 1-bit adder.
One
So
bit.
adder.
Okay.
This is the full bit adder like that. I think we have learned in the
Full adder.
full adder. This is a 1-bit adder. So then this is the ALU. So we are taking from, this is like inputs. We can take from input from register also. Then we are and B, there is a 2 inputs. We are taking 2 inputs, A and B. We are taking from, and we are
Two
displaying.
8-bit inputs are there,
Yeah, and
and
we are
there accordingly 2 splitters are there.
yeah, and this is the whatever the
But there
it's
is this XOR gate, and XOR gate is connected to.
JOR gets connected because you want to do subtract also, right?
Yes.
So if I think you can see there is a button to subtract. So let me. So that's why like this is a yes. If you want to put subtract equal to 1, it will do subtract.
AS is subtract. Okay.
Yeah. So if you put there is a one control. If you put to S equal to 1, then it will behave as a subtract.
Okay. So you are saying that this is an ALU circuit.
Yeah.
Which can do the operation of addition and subtraction.
Yeah, subtraction both.
How is it happening?
That logic is like just watch the lecture. So
Mhm.
that professor explained very clearly, like what is it mean by complement, then 2 complements, then how actually this is happening, A equal to A plus A bar. So how this logic, this circuit come.
Okay.
So
Yeah.
that
What is that thing after XOR gate here?
after that 1-bit adder. If
1
some
bit adder.
if some carry is there, then we are putting the next 1-bit adder.
So A, B, C enable and sum and carry. Okay. And this is carry is going in sequence to other higher bits.
Yeah, higher bits, and you are displaying whatever that output. Sorry, and if there is
There
carry
is something this disconnected here.
yeah, not
So,
disconnected. This is a if you see, this is input size is 8. So this is
okay.
OR get input size is 8.
Asha, those 8 points are there.
Yeah, 8 points are there.
Okay.
Okay, so you have to design this circuit.
Mhm.
So if you that's why like I'll suggest like watch that professor lecture how actually ALU is designed.
Okay.
So that will be clear to you. If it does not clear to you, then message me or discourse.
Sure.
Yeah, up to that is clear. Like this what up to that is clear. 8-bit flip-flop is clear for everyone.
Yes, that
Yes, sir.
designing is clear.
Okay.
One more question, sir. Sorry, I mean, previous relating to the previous stop point is that the ALU, right? So you're mentioning that there is this two control bits, right? Wherein there is this one for subtract. So if you make it 1, then it will behave as a subtractor, right? I'm not sure if that is the right term, but basically subtraction circuit. And if it is 0, then it will be adder, right?
Yes.
Now, so now I think for multiplication is just repeated addition, right? I think
Yeah.
then and similarly for division we have repeated subtraction. So that
Yes.
that accounts for all the 4 primary, I think, operations that are.
Yes.
So would it be correct to then say that whatever ALU circuit we have designed here is actually the circuit that is there in the modern processors also? Like speaking of ALU only, is that all to the ALU, or are there other things which are not shown here?
It's like it's simple ALU that who can that subtract and addition.
Oh, okay. So there are more complicated ALUs
Yeah,
out
more
there, right? I
complicated,
mean,
yeah.
that is what. Okay, yeah. Okay. Like this is the fundamental
Yeah, this is a
concept of what an ALU does in
Yes.
general, right? That is
yes.
okay. Yeah, that is what I wanted to know. I mean, like, okay, when
Yes.
we say that it is an ALU, it doesn't necessarily mean that it is the only ALU that
Yeah,
can perhaps be.
like modern that
Hmm.
any i3 i7 or
Yeah, yeah.
it's like
Hmm.
too much complexity.
Yeah, and I think modern processors might have more than one ALU, in fact, right? Not only one ALU in them, right? So I mean, it matters. Yeah, it's okay. I mean, I just wanted to have
Okay.
that clarified. That's okay. Thank you so much.
Okay, so let's take this is a input. So this is a clock. Okay, now the second question is okay, so now we have designed the 8-bit register using the flip-flop. Okay, so data in means register in and register out, right? And data out means which are 8-bit buses are taking input. So you have to design like that. There will be address, then there will be ROM, then data in, data out will be there. Means register in, register will be there, and uh, that we have to design in such the way that first question is the manually load data from the ROM into register A. So we have to manually load the data from ROM into register A, then load data in register B from from A, right? So first you have to load the register from A, like load the register from ROM. Then after that you have to load the register in B, right? So let's do that, right? So
No, right now, what we did was simple thing.
Yeah.
In and out.
yeah,
And
right.
I mean, implementing the register thing.
Yeah, register in and register out.
And now we have to expand further on this.
Yeah, expand further on this. Yeah, correct. So we have to do like that. So let's
So
do.
looking, so this thing what we have designed here.
Yeah.
And going back to the circuit diagram, what
Mm.
part we have done in that circuit diagram?
So we have done only that 8-bit register. This 8-bit register.
Exactly. Only one. These three things are shown 8-bit register. We have done that.
Yeah, we have done that. Now you have to implement all the things. Okay.
Excuse
So
me, sir. Can you come back to the diagram, please, once again? Yeah. In this diagram, what is the address stand for? I mean, address is basically, I mean, is that a separate component in itself, or what is that?
no, it gives just input like 4-bit address.
Okay. So that is automatically belonging to the ROM. You said we are going to enter it manually, right?
Yes, correct.
Yeah. Okay. So I mean, like in principle, the component that is there is the register itself, I think, and the bus, right?
Yes, correct.
Yeah. Okay. That is all.
8-bit bus one, 8-bit wire. That is
Okay.
like just a wire kind of that.
Wire, yeah. So I mean, like the component then in that case will be just the register itself, nothing more than
Yes, correct.
that. Makes sense.
Okay, so let's the edit layout. So maybe you can increase height. So let do that register in here, then register out, and this is the clock, then out, right? So this is the cell. So this is the, so you can write 8-bit register, right? So edit layout. So you can see that 8-bit register, register in, register and suppose you want to display what the data is actually present in the register. So you can also do. So let's do like that. What we can do? We can do so. Let's here it's a splitter. Control C. So I want to see that data, what the data present in the register, right? So I will be using register out here. So let's do the output.
So one is red only here. The 1 to 3rd one.
So maybe that is 0, right? That's why red. So
No,
if you-
it's extended. Is it so?
oh, it's okay.
Yeah, that's
So 8-bit. So we can see that what actually present in the register. So if register bit is equal to 1 also, we can see that what actually present in the register. So that's why we are using display. So if you want to
I
see,
didn't get this. What? Come again?
suppose register out is 0, so we cannot see what actually data is present in the register, right?
Yes, it is hidden.
Yeah, it's hidden. So if you want to see, then we can use display. This kind before the this is that tri-state buffer. Before the tri-state buffer, we can see what actually data is present, right?
Okay.
So that's why using display. Suppose you want to see what actually present in the register, so you can use the display. Okay, so now let's do that second things. So first we have to 8-bit register. So let's right click, insert sub register. So you can see the 8-bit register insert. So that will be inserted.
How did we save that diagram? I mean, by saving that, it has become like this, correct?
Yeah. So you can that edit layout. You can edit the layout. You can, if you want to move here and there, you can do.
Okay.
So that is 8-bit register, right? So all the control, you can see the in, out, register in, register out, display, all the things is there, clock is there, right?
Correct.
This is register A, this is register B. We have to import 3 register. Just copy control B. So we can D register and then another register. Okay. Now there will be ROM, right? So ROM. So here it will be. So this is the ROM. Read only memory. This is the MOM. So here we can do. This is the NML, right? So this is the NML. So we have to put NML input if you want the element or not. So this is called enable, and we have suppose you want to write into the bus or not. That's why we required one tri-state buffer. Tri-state buffer. This is called tri-state buffer. And suppose
There appears to be an invert version of that too, right? Having a not
yes,
in front
yes,
of it. Yeah.
yes. So if you want to write on the bus or not, and this is bit worth it 8, right? 8, right? And then this is called 8-bit bus. This is called 8-bit bus, right? This is called 8-bit bus. This is called 8-bit bus, right? Okay. Right. Now suppose this is the how many things are there in the this 16 things is there, right? 1 2 3 4 5 6 4 into 4 16, right?
Yes, sir. Yeah.
16, yes.
So we require 4-bit to address. So this is called we require 4-bit. So to address, so to address 4-bit, this is called address. Suppose you want to put something. So suppose 0 1 here I want to put here, you can just put 0 2 0 3 0 4 0 5, kind of that 0 6, right? Suppose this all 0, then 0 1 will be selected, right? Correct.
Right. Sir.
If 0 1, then this 0 2 will be selected, right?
Correct.
If 1 1, then 0 4 will be selected, like that. Whatever the address, suppose this will be selected. Suppose all 1, then last one will be selected. You got it?
What will be the last one?
Last one will be like 50, right? 0, 1, 2, 3, 4, 15. This is 50.
50. Correct.
Okay.
So it is not like that in. Okay, so this will be like 0, 1, 2, 3 in the first row.
Yeah.
And in the last row, it will be like this. It's not like in Kmax
No,
we
it
were
no,
having
it
the other
won't
way.
like. Okay. Now, so register in, right? So we have to connect it all the things into the bus. So register in, register out. This is in and this is out, right? So this is in, this is out, and this is register in. So you have to connect it. We want to put or not register in, and this is the register we want to do or not. Register in, register out. Again, we have to pin in.
So can we share the control bits across the registers, like for register in and out? Is it possible?
This is, yeah, I will share. This is register A. This is register B.
Yeah, so we can share it, right? The same.
Yeah, yeah.
Okay, okay.
So here you can write also register A, I think. Set A, I think. Okay. Register B. Register A. Okay. Now it should be in, and it will take data from the bus itself. Bus itself. Right. Now clock is there, so all the clock will be the same thing, right? So let's put here itself. Clock. Okay. Up to that is clear, right?
Yes.
And this is register B. And this is register C. Okay. Okay. Now, first is the manually load the data from the ROM into register A. First, you have to manually load the data from register A into the register A, right? So, first you have to load the register from this. You have to load the register. So, if you want to display what the things is there, so you can also see. So, you can see that flags is there, sequential element. I think flag miscellaneous. So, if you want to, I think flag bitwise is 8. Right? So, it will give in the hexadecimal format. So, flag is there. So, you can see what actually present in the register. So, this is now 0, right? So, okay, let's see. So, arrive listen, that will okay then. We can see what actually present. Okay. So what will be the control word for first things? First, you have to manually load the data from the ROM to register A. Suppose you want to load the data 01. So it will be 01 address will be 01, right? Correct? Enable should be 1, right? Enable should be 1. And you want to write the data to this bus, right? So this should be 1, right?
01 is address 00.
01.
What? Sorry.
This is the data. So suppose you want to this 0 address. So this is the data 01.
Correct.
You can put anything also like 110 also. What?
Okay.
Yeah. Selected for 00. Then 01 will be selected, right?
Yes. Yes.
This is you can put any. Sorry, what happened? You can put like a 08 also. So you can take input from the keyboard. So suppose 08 want to write on that bus. What will be? This will be 1, right? This should be 1,
Right, sir. This should be 1, and the enable also should be 1.
and this register in should be 1, right?
Yeah.
So register in should be 1. So
Okay.
what happened now? Display not okay. Then you have to clock enable the clock, right? Sorry. So what happened? It's not working. Display should be 08 means like yeah.
No, I think the first register's clock is not connected, sir. There's an issue.
Oh yeah,
The clock, the
yeah,
wire is.
yeah. Now so enable initial it was 0, so you have to put 1, right?
Yeah, that is okay. Okay. All right. We are seeing, but isn't it a problem here in the right side? You see, the connection to the clock of the register is, yeah, this one is not, like, this is going
No,
out.
this is
That is
connected
just
properly.
a extra thing hanging.
Okay.
Okay.
I see.
Now we have loaded the register array, right? 8 things, whatever the data we have loaded the register these things, right? Okay. Now we can put that connection to. Now second thing is whatever we have loaded, you have to load the data in register B from the register A. So you have to load the data this register whatever the 8 into the register B, right? So what should be the control word? So this should be 0, and we have loaded, so this should be 0. Now what would be the control word? So register out should be 1. If
Right.
register out, then it will be load to the that things,
Bus.
right? And register in should be 0, and register out should be 1. Then after that, this register,
Registered in means it will hold that.
yeah, it will take data from the
Mhm.
buffer. So register B in should be 1. So you can see that we have load the register into the B.
Right. And
Yes.
this is not like the actual input. It is not pushing it because it is off, right?
Yeah.
The yeah,
Yes.
the write is off, so we cannot
Yeah.
write it. So it is taking it. It must be taking it from the other register. So yeah, that's correct.
Yeah. So first question is clear.
Yes, sir.
Okay. So also write the control word to achieve that. So whatever the control word means, what a register in, what should be the register in, register out, like kind of that.
So where do we write that?
This is a practice assignment, so you can
Yeah.
write in your copy. So it will
No. I mean, somewhere to write in the circuit I was asking.
no, not in the circuit. Like in your copy, you can write what
Okay,
is the
okay.
register
Okay.
register out. So, okay, right? Now second question. First, you have to manually load the data from the ROM into register A and B, both which must not contain the same data. So both will be like different data. Now swap the content of register A and B. Now we have to swap the content of register A and B, right? So how to achieve that? So first, let's put all the 0, then it will be good. Now first we have to load the data from register A, and you have to load the data to register A, and you have to load the data to register B. Then after that you have to swap the content. Okay, right?
So can we just change it for B, sir? Because for A it is already loaded. So why not just load it into B?
Yeah. So
Keeping A off. Yeah.
so let's load the register B like 04. So what should be the address? What should be the address?
Should be 4, sir, right? 4
no.
is 100.
0, it's 3, right? So you have to put 1 over, right?
Okay, 1. Okay, in that direction. Yeah.
Okay. Now you have to write into the bus. We have to write into the bus, so it should be 1, and register in that B should be 1, right? And
Right.
this should be 1. So you can see that both are
Hmm.
loaded in different data, like one is 4 and one is 8, right?
Right. So before we move forward, one more question. So I just thought of this. So
Yeah.
what happens if there is a conflict? Let's say if the register is also trying to write to the bus as well as the memory is also trying to write to the bus, then what
This will
happens?
occur as bus conflict.
Okay,
This
bus
will
one.
bus it, this is called error, like bus conflict. You
Okay,
can
no,
say
so
that.
but then again, what will be the data? We don't know. Like it is undeterministic, is it?
Yeah, it will be like, I think
Okay.
anything can be happen. So you have to
Anything
see.
can. Okay. I understand.
No,
Okay.
so we loaded the data first in register A,
Uh,
then we turned off the register in for register A.
Yeah.
Then copied the same into register B.
Yeah.
Now how are we for swapping again? We have to load other data in register A. Correct?
no. You can see that already loaded the 8, right? So
Yes.
and register A contain 8, so just loaded the register B, whatever that.
Achha, register B we are loading separately 4.
Yeah, separately for, right?
Okay.
Okay.
Now
Now,
we will be swapping.
yeah, now we'll be swapping in the register C. How to swap? First, you have to
Temp.
whatever.
We'll be using register C as temp.
Yeah. So whatever that register A content will be loaded into the register C, right?
Yeah, anything, either A or
Yeah.
B.
Yeah, either A or
Okay.
B can.
So what should be the control word? Register out should be
Register
One.
out should be 1, in should be 0.
yeah.
Yeah.
Register out should be 1.
And for
and
C it should be one. In
It
should be one.
is
Yeah.
C should be 1. So you can see that it's
Yeah.
loaded, right?
Correct.
Okay.
Now it is 848.
Yeah. So
Now
now
we can do register out for B as 1.
output B is out is
Register in is already 0.
Yeah.
And then register in for A to be 1.
register A and B 1. So you can see that 4 is loaded, right?
Correct.
Now what should do after
Now
that?
same thing between C and B we should do.
Okay. So register out should be 1.
1,
Register
in should be 1.
Yeah. So now we can see that.
Yeah. And the temp remains. We need not
Now,
clear it, is it?
yeah, if we need to clear C, then what to do?
It's it's display, right? So like this is if you see that it display already whatever the data is content. So you can put 000.
Okay,
So
I mean, we don't care about C
that will
anyway.
not go. So this like how register, this is called register transfer logic. How actually do that register transfer? Like in a very low level, like in a very like you can say that in C or in Python just we write the whatever the code, but how actually it's occurring. So you
Correct.
can
Yeah,
simulate all that.
these are placeholders basically.
Yeah. So you have done that to practice assignment. So now how to submit that? So if you have done one, so how to do that? So there is a project, then you have to export. I think export as a file. Export as a file. So file name you have to give. Suppose question number one, and save, right? And suppose question number 2 is there. This is so project. Then export as a file. Then this is suppose question number 2. Question number 2. Save. Then after that you have to zip 2 files. These 2 files you have to zip, and then you can submit in the portal. And we'll evaluate like according to the question number. Got it, everyone?
Is
Yeah,
it
so
possible
that
to
will be
have this?
manual.
Yeah.
So that will be a manual evaluation.
Yeah, that will like I'll be evaluating all the like I
Okay,
think 40 or whatever the 50 student is there. So I'll be according to I'll give marks according to whatever you have done in your.
Okay.
So first thing
Excuse
is
me, sorry to interrupt again. One more question. So is it possible to have this like the exports with us, shared with us on Discourse maybe for the practice assignment?
can you repeat?
Like the export, the export from this that you have done, right? These diagrams. Is
Yes.
it possible to share with us on Discourse if possible? I mean,
We cannot say because that things this 8-bit
Mhm.
register is the question number 1 if you saw.
right. Okay, the same
But
thing. Oh,
We want like at least do some
Right, right.
do in that
Oh,
circuit
okay,
bus.
okay, okay. I mean,
So that
okay, graded assignment also has that same question. So one
uh-huh.
might, okay, okay. I understand. It's okay. It's okay then in that case. Yeah, I
So
understand.
it will be like you want to like do some simulation in your own way.
Right, right.
And this is the 8-bit ALU register. So ALU, I think you can refer to this lecture video. Yeah, like we design 8-bit ALU from scratch. So
Okay.
that will be. So it will require like I think 1 or 2 hours to do these 2 questions.
Okay.
Okay.
And
yeah.
the how to do this? What is the ones complement in 4-bit system of binary number 1001?
So 1 bits complement, I think just you have to swap that. If 0000 is there, then okay. So 1 bits complements, suppose 000, 1 bits complement will be 1111. Just you have to swap the bits.
Flip the bits.
Yeah,
Okay.
flip the bits. So I will suggest like at least watch the professor lecture video, then it will be good.
Okay.
Yeah, so I think all the things is there. Okay, so
Sure, sure. Thank you. I mean, this was quite elaborate.
yes. Okay, so any doubt other than that? Oh, the next week will be one revision session will be there.
For
So
end term, right, sir?
yeah, for end term there will be one revision session. Maybe we'll start at 6 or something. 6 Thursday 6 any session?
Thursday.
Thursday 6 next Thursday. Like from
Yes,
any degree level session is there or not?
25th of April, you are saying?
25th. Or if you want like before than that we can do also. Like if you want
25th April, there is no session as of now.
okay
Nothing
then,
is scheduled.
okay then maybe we'll send the announcement to all the students that at 6 revision session will be there. And there will be
Six, right? Yeah, okay.
yeah, and there is a one mock also, so maybe we'll release that mock also.
Mhm.
So before that, try to solve all the. I'll solve basically mock question in the revision session, so you'll get how actually we asked in the end term question. What are the question we
Okay.
asked?
And if required, we can request you for additional session in between.
Yeah, yeah. If you like anything you want, then we'll be conduct separately session.
Okay. Okay.
Yeah.
Thank you.
Okay, then good night, everyone.
Thank you. Thanks for
Thank you.
this.
Thank you, sir,
Good
for
night.
this session. Yeah,
Yeah.
good night.